Now, so now let's see what exactly the ORM feature, what it represents, why Salesforce is purely supporting the ORM, and what is the ORM architecture internally, what it will do basically here, and how can we interact with the database objects. It may be standard, it may be custom object, through programming to manage the records inside that we'll see practically now. Okay. As of now, we have created the records by using user interface or by using some data loader to manage the bulk records also. But now I would like to manage the records inside my object through programming also. Then how can we manage the records through programming? It may be single record, it may be the associated records, it may be the bulk records also. How can we manage through programming? We'll see practically. Okay, now. So now in this case, first of all, we have to understand what exactly the ORM, what it stands for, and then how it is transforming your Salesforce objects into the various classes and the fields into the members inside the class. Okay, now let's see. So now first of all, we have to know what exactly ORM stands for. ORM in the sense what is the full form of this ORM? Now, ORM stands for Object Relationship and Mapping. Okay, ORM stands for Object Relationship and the Mapping. So then what exactly this ORM basically, what it will do internally here? Now, when coming to the Salesforce, Salesforce is purely supporting the ORM. Okay, Salesforce is purely supporting the ORM functionality. Because of that, whenever I'm creating a new object in Salesforce, Salesforce is providing all the 3 layers of your application in one shot. Like whenever I'm creating an object in Salesforce, okay, by using some navigation, by using some standard navigation, whenever I'm creating a custom object, Salesforce is providing 3 layers of your application. What are those 3 layers? It is providing user interface. User interface is available in terms of what? Tab, right? Okay. Then table, okay, and then controller. That means business logic. Okay. Now, for example, whenever I'm creating a custom object, okay, for example, I'm creating a custom object with the name some loan. Whenever I'm creating a custom object with the name some loan, then it is providing all the 3 layers of your application. Like it is providing the table, that means which is called as the modal part, and the second one, it is providing the user interface, that is also called as tab, in terms of tab, which will be referred as the view, and the third one is the business logic, or this is also called as controller, which will be available in the form of a class. Okay, which will be available in the form of a class. Generally, when you go to some other programming languages, okay, when you go to some other programming languages, it may be Java, .NET, or any other programming language except Salesforce. Okay, except Salesforce, when you go to any other programming language, if you want to store some data by using some user interface, first of all, we have to design the table first. We have to design the table by using the database programming. It may be SQL or PLSQL programming. By learning the database programming, we have to design the table with the required columns. Okay, now, once the table is ready, okay, once the table is ready with the required columns, then according to the table structure, based on the table structure, we need to design the user interface. Okay, as a second step, we need to design the user interface. By designing the user interface, okay, with the help of that various web technologies like as HTML, DHTML, JavaScript, all these things we can use to design the user interface. For that one, we need to learn these web technologies. We should be aware of HTML programming, DHTML, CSS, JavaScript, all these programming languages we should be aware of. Once the back end is ready and the front end is ready, then to provide the communication between these two, we need to implement the mediator part that is called as controller. Okay, that is also called as business logic. So we need to implement the business logic as a third step. Okay, this application development flow. It may be any project, any technology, any programming language, application development flow will be like this. Okay, first of all, we have to develop the database, design the database first, and then design the user interface. And as a step 3, we need to implement the business logic. Okay, but whenever we are running the application, whenever you are accessing the application, we are accessing the user interface first. User interface to business logic to database. Database to business logic to user interface. This is the flow of application execution process here. Development flow will be database first and then user interface, and then we have to implement the business logic. Okay, model and then view and then control. Okay, this is the flow we have to follow upon developing the application. Okay, first of all, we have to design the model part and then the view part and then the controller part finally here. Okay, now in this case, first of all, it is going to building the model part here. So now what is that model? Model means what? Database. Now whenever I'm creating an object with the name some loan, then Salesforce is providing a table or not? Yes. What is the table name? I'm creating the object with the name loan. Then what is the table name now here? Loan. Simply loan or what? Loan underscore C, because this is my custom object. So it is postfixing that object name with underscore C. Next, once the table is ready, in this table it is providing 5 columns to you by default. Upon creating the object by using standard navigation or by using schema builder also, by default Salesforce is providing 5 standard fields like the ID field, name field, owner, created by, last modified by. These are the 5 fields will be given by Salesforce by default here. Now according to the table structure, it will be designing that user interface here. User interface is available in the form of what? A tab. Now, so what is the tab name in this case here? Loans, right? Okay, so now tab name should be always in the plural format, object name should be always in the singular format. You know that concept here. Already we have discussed. Next. So now once the model is ready and once the view is ready, then how can we connect this model to the view? For that one, we need a business logic here. Business logic will be available in the form of what? Class. What is this class name now? Loan underscore C. So whatever the table name that we have, exactly with the same table name, it is providing a business logic class also. Okay, business logic class also. So this is the class is going to be providing by the Salesforce. Okay, this the class has been given by the Salesforce to you by default over here. Okay, now in this case, as soon as whenever I'm creating a new custom object with the name some loan, then Salesforce is going to be creating a table for me. It is providing the tab and it is providing that business logic also. Business logic has been given by Salesforce in the form of a class. You know what exactly class, how the class look like, what the class contains, how to access the class members, everything you are aware of that here now. Okay, now in this case, whenever I'm creating an object with the name loan, then Salesforce is providing a class also. Then what this class contains now? What we have inside this class here? Numbers. What numbers are there? What variables are available inside that class? Basically, these class we can't see. Because this classes has been preparing by Salesforce itself. These classes we can't see here. Okay, we can't see those classes. So now that already you are aware of that, whatever the classes has been created by the user, all the classes will be storing in which object? Apex class object. So now let me go to that Apex class object here. Let me query the information. Now, I am querying that information over here. I am querying this information. Let's see practically what will happen. I would like to query that information. Let me go to the developer console. Let me query the data. Now, so I'm querying that information by using query editor. I would like to collect all the Apex class IDs, name from Apex class. So now here let me execute that. Click on execute. These are the classes here. These classes, we have prepared classes here, but Salesforce is giving the class. For account object, one class should be there. Contact object, one class should be there. For my position object, one class should be there. Where is those classes now? Those classes code will not be visible to you. Abstraction. Okay, abstraction. Because purely they're hiding the data here. They're not exposing to you. Because if the class is visible to you, if you're able to see the class code, then at that time, the other cloud vendors also can see this class code. Similarly, they can able to implement that their own cloud implementations also. Okay, so for that reason here, Salesforce is not exposing the classes here. Whatever the classes has been given by Salesforce, we can use those classes, but we can't see the class code what we have. Okay, we can use that class code, but we can't see what class code they have implemented. We can't see that information. Okay, that's how they have restricted completely here. Your own classes you can see. If you want to see your own class information, then you can see your own class information also. That possibility is available, but the Salesforce provided classes we can't see. Okay, now in this case here, when you go to that ORM, whenever I'm creating a new object, automatically Salesforce is providing a class also. Okay, Salesforce is providing a class. Now in this case, so now the table name and your class name will be exactly similar. Whatever the name has been utilized by the Salesforce to create the table, with the same name exactly it is going to be creating the class also, business logic class. That means what? Whatever the table that we have, the table is going to be transforming to that class. The table is going to be representing in the form of class. Okay, the table is representing in the form of class. Okay, now in this case, the table name and the class name exactly same. Okay, now for example here, come to a scenario. Assume that I'm creating a object here. Okay, I'm creating an object. I'm creating an object with the name some customer. So now tell me what is the tab name? So what is the table name? Customer __ C. This is the table name. Now, what is the tab name? Customers. And the third one. What is that business logic here? Business logic class name is customer __ C. Okay. So now we are having this customer table. Table is having some columns. What columns has been given by Salesforce by default? 5 columns has been given by Salesforce. ID column, name column, owner column, created by, last modified by. These are the 5 columns are available here. Now, next one, for example, I am having this account object here. I am having this account object. It's a standard object over here. Object is account. Now, in this case, so what is the table name? Account. So why it is simply account? Why not __ C? It's a standard. Okay, it's a standard one. That's what here. Standard object names are simply like as a normal words. But the custom object names are always postfixing with __ C. Okay, now. So what is the tab name over here? Accounts. And what is the business logic class? Okay, business logic class is account. That means what? Each and every object. Okay, each and every object. Object means what? Table. Every table has been represented in the form of a class. Okay, every table has been represented in the form of a class. What are the tables that we have? That each and every table will be represented in the form of a class in Salesforce with the help of ORM. What the ORM will do? Object, relationship, and the mapping. That means what? Whatever the object that we have created, that object is going to be representing in the form of a class, and then this two it will be mapping automatically by default. So that with the help of this class, we can able to connect to the object through programming. As of now, we have interacted with that object by using user interface. But by using user interface, how many records can I create at a time? How many records we can create by using the user interface at a time? Only one. How many records can I modify at a time? Only one. How many records can I delete at a time? Only one. Not multiple. But sometimes I want to create multiple records. I want to modify multiple records. I want to delete multiple records in one shot. At that time, that user interface won't support to me. In this case, through programming, I want to do that. So in order to connect to the database, I need a mediator. I need a helper. That helper is nothing but the class, business logic class, which has been given by Salesforce here. So that directly we can able to connect to that, the object with the help of this class. Through the help of this class, we are going to be connecting to that object and we can perform all the DML operations on one or more number of records inside that object in one shot. Not only inserting one record, not only updating one record, not only deleting one record, we can perform the operations on multiple records in one shot with the help of this class, which has been given by Salesforce. So now whenever I'm going to be creating the table, now along with the table name, it is creating a business logic class also, where exactly the business logic class name and your table name will be exactly similar. So now with the help of this business logic class, we can connect to the table through programming. Okay. Through programming, we can connect to the table with the help of this class, and then we can perform all the DML operations on your table records. Not only on one record, we can perform the operations on multiple records in one shot. Okay. Now, this is the internal concept of ORM. So what the ORM will do, ORM is going to be representing each and every table in the form of a class. Okay. Every table will be representing in the form of a class where the table name and the class name will be exactly similar. Okay. Clear? The first point. When coming to the ORM, the first functionality of the ORM is whenever I'm going to be creating that table, then the table is going to be representing in the form of a class, where the table name and the class name exactly similar. Then who will create this class? Salesforce will create this class here, because Salesforce is internally using ORM functionality. Because of this ORM functionality, it is creating this class by default here. Okay? Understood the concept here? Now, the first point is, when coming to the ORM, okay, when coming to the ORM, ORM is going to be representing each and every table in the form of a class. Okay? Now make a note over here. ORM. Salesforce purely supports ORM functionality purely supports ORM functionality because of ORM, upon creating an object inside the organization, it provides all the three layers of the application as below. All the three layers of the application as below. It is providing the modal part upon creating a custom object here with the name some loan. It is providing that the table. Nothing but database. Modal, or this is also called as database. User interface. Okay, this is also called as view. Business logic or controller. This is called as class. Now, Salesforce purely supports ORM functionality because nowadays, when you go to any latest frameworks providing by the other programming languages, like when you go to Java programming, the people are learning core Java first, and then advanced Java, and then J2EE. Once they are learning the J2EE, then finally they are going to be learning some frameworks, like some Struts framework, Hibernate framework, Spring framework, Hibernate framework, the various of frameworks the people are learning, because those frameworks are purely built upon ORM. But In the year 2000 itself, Salesforce is being purely built upon ORM. Okay, in the olden days itself, these people has purely used that very latest technology at that time. Okay, so that's what here, because of that ORM only, Salesforce people have not relied on any custom database. When you go to SAP, SAP is purely relied on Oracle. Okay, SAP purely relied on Oracle. Through SAP application, whatever the data that you are going to store, that will be storing inside the Oracle database here. So upon installing the SAP into a local system, automatically Oracle copy also will be getting installed, because SAP is purely built upon Oracle database. They are purely relied on Oracle database here. Suppose in future, if the Oracle people has increased the licensing cost, then if the Oracle people has increased the licensing cost, then SAP license also they have to increase here. Okay, SAP license also they have to increase. So in this case, because of the huge demand of some SAP, if the Oracle people thought of SAP people are getting huge profit because of our database, then why can't we increase our database license cost? If we are increasing the license cost, then automatically SAP people has to increase that cost here. Then keep on every year, if I am increasing the licensing cost, then SAP people also keep on increase the licensing cost. If the licensing cost has been purely increased, then people won't show interest to use SAP. That is a major problem. Okay? Because if the licensing cost is very high, then the people won't show interest to use that SAP here. Because of that, this is a major problem here for why the SAP has been the downfall nowadays. Very few customers are utilizing SAP nowadays. Most of the people has been migrated to Salesforce. Previously, mainframe applications has been migrated to the SAP. But now, SAP applications have been migrated to Salesforce. Because Salesforce licensing cost is very, very less, very, very cheap. That too, it is purely a cloud-based. It's purely cloud-based. But more security features are available inside of Salesforce. That's what here, after so many years, SAP people got realized that because of that Oracle database increasing the cost, licensing cost, we have purely increased that our SAP license cost also, so that here we are unable to capture most of the market nowadays. That's what here, instead of using the Oracle database, they have decided we don't want to continue with the Oracle database from now onwards. We would like to design our own database from now onwards. So that they have introduced that SAP HANA. Okay, SAP HANA. So it's a customized database of SAP people. Okay. So now from now onwards here, SAP people are purely integrating their SAP applications with that HANA database only. Slowly they are going to be integrating all the SAP applications with HANA. Once all the data has been migrated from Oracle to that SAP HANA, then they will decommission that Oracle database. Okay? They won't use that Oracle database here because they would like to continue to use their own customized database. Okay? So now after so many years, SAP people got realized. But when coming to the Salesforce people, they got this idea, okay, in the year 2000 itself, in the beginning itself. That's what from the beginning, they're purely using their own customized database, that is, okay, database.com. Salesforce people are not relied on Oracle. They're not using SQL Server database here. They're purely using their own customized database, which purely supports this ORM functionality here. Because of this ORM functionality only here, so they are able to create the table. According to the table structure, they are creating the user interface, they are creating the business logic class also. Generally, other databases won't support all these things. It may be Oracle or SQL Server. When you create the table, only table is created, not the user interface, not the business logic. But Salesforce is the only organization which purely supporting the ORM functionality here from the beginning itself. Because of that here, upon creating the table, Salesforce is providing all the 3 layers here so that they are avoiding the coding part. So no need to design the user interface manually, no need to write the business logic by your own. Everything has been given by Salesforce by default, so that the coding part has been reduced, application development has been, the development time has been reduced, so that you can be able to save the budget also. Okay. So for that reason here, so many people are adopting the Salesforce implementations. Okay. Now, in this case, when coming to that Salesforce, they have reduced the coding with the help of ORM functionality. So that whenever I'm going to be creating a new object in Salesforce, automatically it is providing all the 3 layers of your application, because it is providing the table, it is providing the tab, it is providing the business logic class also in one shot. Okay? Clear? Now, that means what? Each and every object will be representing in the form of a class. Okay? Now, Now here in this case, note. ORM transform each table, that means object, each table in the form of a class. In the form of a class, where the table name and the class name should be exactly similar. Exactly similar. ORM transforms each and every table or object in the form of a class, where the table name and the class name is should be exactly similar. Like for example, object name and the class name. Now my object name is account, contact, opportunity, and the case, and the lead, and the solution, like that. And I'm having my position object, and my customer object, my hiring manager object. So many objects that we have inside my organization. It may be standard, it may be custom also, whatever. Each and every object will be transforming in the form of a class. Whatever the objects are available inside your Salesforce instance, each and every object has been represented in the form of a class. Okay, every object has been represented in the form of a class, where your object name and the class name will be exactly similar. Account table has been represented in the form of account class. Contact table has been represented in the form of contact class. Opportunity table has been represented in the form of opportunity class. And the position underscore underscore C table has been represented in the form of position underscore underscore C class. That each and every object has been transformed. That means representing in the form of a class. So this is the functionality of ORM. Now, in this case, for example, done with these points? Madam, screen is visible to you? Or else come to the front. The people who are unable to see the screen properly, then come to the front. We have the chairs are available. Done? Now. So now here in this case, that means what? When coming to my account class table has been represented in the form of class. Okay? Now. In this case, how the class syntax will be? What is the class syntax? Access specify class name. You will be having some body of that class. Nothing but some members are available. That means here. Now, in this case, account table has been represented in the form of account class. Account table has been represented in the form of account class as below. How the class structure will be? It will be representing in the form of public class. What is the name of this class now? Account. It will be having some business logic inside this. That means members. Okay. Now, your lead object here, nothing but the lead table, has been represented in the form of a lead class as below. So what is that lead class here now? How the lead class will look like? Public class lead. You will be having that members. I'm having my position object class, position object here. Position table has been represented in the form of position underscore underscore C class as below. How will be the position class now? Public class. What is the class name? Position underscore underscore C. That's it. Now tell me, can I use the character underscore inside my class name? Can I use this underscore characters inside our class name? Yes. That already we have discussed. When coming to the class name can have alphabetical characters, alphanumerical characters also, along with the special character that is underscore. Because that already we have discussed. Other special characters will not be acceptable, like as dot, comma, semicolon, hash. These will not be acceptable. Only underscore will be acceptable in that class name or in the variable name also. You will be having that members. Now, my loan table, loan underscore underscore C table will be represented in the form of loan underscore underscore C table as below. So public class loan. It will be having some numbers. Now tell me, who will create these classes? Do I need to create or will Salesforce will create? Salesforce will create automatically here because Salesforce is purely using ORM functionality so that these classes are preparing by Salesforce itself. Okay. Now, in this case, whenever I'm creating the table, these classes has been prepared by Salesforce itself by default. We no need to prepare this class. This has been given by Salesforce to me. Okay. Just we are using that class. That's it. Clear? Now, so now whatever the object that we have in Salesforce, it may be standard or it may be custom object. Every object has been represented in the form of a class where the class name and the table name will be exactly similar. Now, if it is a class, then definitely the class will be having some members, right? It will be having some variables, some properties, some functions, some procedures, some constructors we can have. Now in this case, will this class is an empty class or do we have any members inside this? Members. Then what are those members here? Then what members are available here? Now, in this case, whenever we are having the table has been represented in the form of class. Table contains what? Fields. Okay, fields. It may be standard field, it may be custom field also, whatever. Now, each and every field inside the table will be representing in the form of variable. Okay, inside that. Observe this one. So now, whatever the table that we have, table has been represented in the form of class. In the table, whatever the fields are available, every field will be representing in the form of a variable inside this. Okay, now in this case here, for example, let me explain. For example, I'm having an account object here. I'm having an account object. Inside my account object, I'm having so many fields are there. Account ID field, name field, rating field, industry field, annual revenue field, and the type field and the ownership field and the phone field and the fax field. Like that, so many fields are available inside my account object here. Now, so this is my account object. Account object. In my account object, I am having so many fields are available. We are having the ID field, name field, rating, industry, and the annual revenue, and the type, and the ownership, and the phone, and the fax. Like that, we are having some more columns are also available over here. We have so many other columns are also available. Like here, we are having the columns like website, billing city, billing state, billing postal code, billing street, billing country, ESLA, customer priority, and the active status. Like that, so many other fields are also available. Okay. Now, in this case, whatever the account object that we have, that account object is going to be representing in the form of an account class. Okay. Whatever the account object that we have, that account object is going to be representing in the form of an account class in Salesforce. Now, it will be representing in the form of an account class. Now tell me how the class will look like over here. Now tell me how the class syntax will be. Public class account. Okay. Now what is the class name here? Account or accounts? Account. Simply a single word. Okay. Nothing but it's a singular format. Table names are always singular format. Only the table tab names are plural format. Okay. Now the class will be available. In this class, what numbers are available here? Whatever the fields are available inside my object, every field will be representing in the form of variable. Okay. Now the first field, for example, ID field. ID field is referencing which data type now? What is the data type? ID or integer? Integer or ID? ID. Okay, because here ID will be having what? 18 characters ID, which will be alphanumerical values, which is a purely case sensitive. You know that concept over here. Whenever I'm creating a new record, for every record, Salesforce is allocating a 18 characters alphanumerical number, so which is purely a case sensitive ID generating by Salesforce. So all the ID fields are referencing which data type? ID data type. So that it will be having the variable public ID. Okay, the field name is ID. Next, the name field. Name field is of type what? String. Why string? Name is a text box. Text box is referencing which data type? String data type. That already told you. In our initial classes here, during that Salesforce development, already told you over there. So now during that initial classes, that already told you here. When coming to string data type, each text field, text area long, text area rich, email, URL, text encrypted, auto number, phone, geolocation, pick list, all these fields are referencing which data type? String data type. You know that concept here. In our initial classes, we have discussed as part of development. Now, so that here we are having that name field. Name field is referencing which data type? String name. I'm having rating field. Rating field is referencing which data type now? String. Because rating is a pick list. We are having hot, warm, cold. These are what? String values. Next, I am having that industry. Industry is referencing which data type? String. So that industry field also. Next, we are having the phone number. Phone field is what? String. We are having fax field. String. And then we are having type field. Because prospect, customer direct, and then technology partner, like that. We are having what? String. Next, ownership. Public, private, subsidiary, others. 4 options are there. These are also string type. Ownership. And then we are having that website field. A website is also string type. And then we are having that field called as, like as billing street. What is that? Billing street. And then billing city. And then billing state. And then billing postal code. And then billing country. And then SLA. Okay, SLA field. Active status field, because SLA will be having the various options. Gold, bronze, silver, like that we are having the options. Active status, we are having yes value, no value here. So that this is also of type string. Customer priority. Customer priority is having the values like the high, medium, low, like that here. So these are all are referencing string data type here. Okay, these are all are referencing string data type. These all are referencing string data type here. Okay, now that means what? Inside my object, whatever the fields are available, each and every field is representing like as a variable inside the class. Now inside my object, I'm having a field called as annual revenue. Annual revenue is of type what? Decimal. Why decimal? Annual revenue is a currency type. Currency field is referencing which data type? Decimal. Right. Now, public, decimal, annual revenue. Next, when coming to my object here, I'm having a field, okay, owner field. Who is the owner of my record? Some development user, testing user. Then, in this case, what is that field here? What is the data type? Owner in the sense what it contains? Owner of that record. Who is the owner of the record? User. How to identify each and every user record? By using what? ID. Now in this case, owner ID field contains what? ID of that owner record here. Now in this case, that is also ID field. Okay. The field name is owner ID. Field label is simply owner. The field actual column name is owner ID field, which will be holding the ID of the user, okay, who is the owner of that record here. Okay. Now, inside my object, I am having 2 more fields are there. Created by, last modified by. Now, in this case, now tell me here, created by and the last modified by will be of type what? Then, what it contains? Created by, last modified by. Date or date time? Date time, both. It will be holding that. Date time, created by, comma, last modified by. Okay, now. Like that here you will be having the fields available inside this. Okay, that means what? When coming to the Salesforce, because of that ORM, whatever the tables are available, each and every table will be representing in the form of a class. Whatever the fields are there inside the table, every field is representing like as a variable here inside this class. This is the internal concept of ORM. Who will prepare this entire class? ORM. Nothing but Salesforce will prepare by default with the help of ORM functionality. So we no need to create this particular class here. Okay? Clear? This is the internal concept of ORM. So that means what? Whatever the objects are available in Salesforce, every object is going to be transforming into that respective class. Now in this case, each and every field inside that object will be representing in the form of a variable. So this is the class will be given by Salesforce by default. Whenever I am going to be creating an object, then Salesforce is creating that class. Okay? Clear? Now, whenever we are going to be interacting with this object here, okay? Whenever, if you want to interact with this object here, through programmatically, then we have to use the help of this class. With the use of this class, we can able to connect to this object, we can perform the operations. Now tell me in this case, whenever if you want to create the record inside my object, what fields are mandatory in this case? Inside my account object, what are the mandatory fields that we have? Last name, only name field. Okay, name is a field which is a mandatory field. Remaining all are optional here. Okay, now we are having that name field is available here. So in this case, how you are creating the record? Through programming I want to manage. Because by using user interface, I can create only one record at a time, but now I want to create multiple. At that time, through programming also I would like to manage the records here. At that time, if you want to manage the records with the help of this particular class, then in this case here what needs to be done? We need to access these members, I need to assign the value. Okay, in order to supply the value for this particular class variables, okay, in order to supply the value for this class variables, we need to access this each and every member. Then how can we access the members of this class? I need to create a record inside my object. To create the record inside the object, we need to supply the value. Some mandatory fields are there. For example, assume that I am having the name is a mandatory field here. Okay, for example, name is a mandatory field. And then annual revenue is a mandatory field. Phone is a mandatory field. And then industry is a mandatory field here. Assume that these are the 4 mandatory fields are there. I want to supply the value here through programming. How? Now this each and every field is representing in the form of what? Every field is representing in the form of what? Variable. So now here we are having the respective variables are available, right? Name variable is there, industry variable is there, phone is there, and then we are having the annual revenue variable is also there. How to assign the value for this variable now? Then, in order to assign the value for this class variable, then what we need to do? We need to access that class variable. How to access the class variables? By creating object here. Now for which class I need to create the object now? Account class. Now create the object of this account class over here. Okay, now create the object of this account class. Now, so I'm creating the object of this account class right now. How to create the object of this account class now? Tell me how to create the object of this account class. Account, some ACC equals to new account. Okay, now fine. Next. Then how to supply the value for name field? ACC dot name. Then ACC dot name. Name is of type what? String. How to supply the value by enclosing in that single quote here. Now I'm giving like some Ram Kumar. Next. ACC dot rating. I'm passing the value. How can we pass the value? This is also of type string. And then ACC dot industry. I'm giving the value some banking. ACC dot annual revenue. How to supply the value? This is what? Decimal type. Then how to pass? Do you want to enclose in single quote? No, not required. I'm indicating like some 12 lakhs. Now, ACC dot phone. Phone is a string type, so I'm enclosing in that single quote. Because phone value is having some braces. That's what it is a alphanumerical type. That means string type. And then ACC dot fax. I'm passing the value. Now, I'm passing for the remaining fields. I'm passing the value here in the right side here. ACC dot customer priority. __ C. So what is the value? I'm passing some value high. I'm passing that SLA field. Now ACC dot SLA __ C. I'm giving like some silver. I'm indicating that ACC dot active status. I'm passing the value some years. Now I supplied the value for all the fields here. Whatever the mandatory fields are there, I supplied. Now I want to create the record. How to create the record now? In order to create the record inside your object here. So where the record values are available inside a variable called as ACC. This is an object. So now simply insert that record. Insert ACC. That's it. Done. Over. Your record will be creating into your object here. Okay. Simply what we did, How many steps you have performed now? Tell me. Do we need to create this class? No. This class will be given by whom? Salesforce. So forget about this class part. Now, as a step, as part of our implementation, what we need to do? First of all, create the object of this class. Next, as a step 2, assign the value for the required fields. Now tell me, if the table, if the class is having some 100 variables, do one need to assign the value for all the 100 variables? No, because every variable is representing a field inside your table. So in the table, some fields are mandatory, some fields are optional. So please identify what are the mandatory fields are there. For that mandatory fields only supply the value, remaining fields we can leave it blank, no problem here. Okay, now in this case here, I'm supplying the value for the name field, rating, industry, annual revenue, phone, fax, customer priority, SLA, active status. Along with this, we are having so many other variables are also available, but I'm not supplying here because those are not required for me. So I'm not supplying. Once we are supplying the value for that variable, then we need to insert the record into the object by using simply insert statement, insert ACC. Okay, now. Once the record is inserted successfully, then what is the guarantee to me that my record is inserted successfully? If the record is inserted successfully, then what is the guarantee to me? My record is inserted. Now, how can you get the confirmation that your record is inserted? What we can do? ID. Then it will be returning what? ID value to you. Okay, if the ID has been generated, that means what? Record is created successfully. How can we get the ID value here? How to get the variable value? ID is a variable. How to get the variable here? By using that object name dot variable name. That's it. In order to access the variable, in order to assign the value, we need to use the same, that is object. Object name dot variable name. That's it. So now I would like to get the confirmation. I want to verify if ACC dot ID value. I'm accessing that. So now in this case, that already you are aware of that. If you want to assign the value, we have to use a different syntax. If you want to retrieve, that already we have discussed that as part of object-oriented programming. If you want to assign, we are using this as syntax. If you want to retrieve, object name dot variable name. Same concept here also, nothing different. Now, I would like to access this variable here because once the record is inserted successfully, Salesforce is allocating the ID for this record here. That ID will be storing inside my variable. I would like to collect that. If the ID value not equals to null, that means what? ID has been generated. If the ID is generated, that means what? Record has been inserted successfully. So I want to display the message system.debug. Here I am writing this code here. If the ID is generated, system.debug, I am indicating account record created successfully. ID I want to show. What is ID? SEC dot ID. That's it. Done. These are the steps. Now in this case here, what we are doing, whenever you are going to be inserting the record inside the object, what we need to do? How many steps you need to follow here now? Tell me. Then we have to follow that 4 steps. What are those 4 steps? As a step 1, first of all, we have to create the object of the class. Second step, assign the value for the required fields. Third one, insert the record by using insert statement. Fourth one, display that record confirmation. That means record has been inserted or not. For that one, we are using that system.debug statement. These are the 4 steps. That's it. Okay? Understood the concept here? This is the process we are following from now onwards to manage the records inside your object through programming here. Now tell me, do I need to create this class by my own? No. No need to create this class. This class has been already given by Salesforce to you. These variables are already available over here. Okay? Clear? Now. So now here in this case here, for example, you can raise a question. Sir, suppose for example, after some time, if my client asks me to add a column, okay, inside my table with the name some PAN number. My client has given a requirement to me, so now please create an additional column inside the table with the name PAN number. I have created a field now, which is my own custom field according to the application requirement here. So I have created the field with the name PAN number. PAN number underscore underscore C. It is a custom field. Then what will happen in this case? I want to supply the value for the PAN number field also. How? Whenever I am creating that field, then what will happen? The same field is visible on the user interface, right? Yes. The same way field will be representing inside your class as a variable also. Now PAN number is of type what? Text type. Text type is referencing which data type? String. So that it will be adding that variable automatically by default inside this. It will be adding that variable also. Here it will be adding that variable by default. Like as a PAN number. PAN number underscore underscore C. It will be adding the variable automatically by default. So no need to do this one manually, that will be taken care by Salesforce itself. Okay, it will be adding that variable. Suppose for example here, that means what? Whenever I'm adding a table, then whenever I'm adding a column inside the table, automatically the column is going to be representing inside the user interface. Automatically the column will be visible inside your business logic class also. Suppose after 1 month, my client said that we are not using this PAN number column, so please remove this column here. If I'm removing this column, then what will happen? Automatically, this variable also will be getting removed by Salesforce here. Okay, that means what? Whatever the operations we are performing on the object level, the same operations are reflecting on the user interface as well as business logic class also by default here. Whenever you keep on adding some new fields inside the object, automatically the respective variables will be adding inside your class also. Suppose if you are removing the field, automatically the variable also will be removing from your class by default. This is the internal concept of Salesforce. That means what? If you make the changes in one place, it will be reflecting in all the 3 layers of your application in one shot over here. It will remove the column from the table. It will remove the text box from the user interface. It is removing the variable from the class also automatically. All the 3 layers will be getting affected in one shot by default. Okay? Clear? This is the internal concept of ORM. That's how here Salesforce is going to be avoiding the much coding part upon implementing the records through programming inside your Salesforce instance. Okay? Clear? Understood the concept here? Yeah. So when coming to that Salesforce, it is purely supporting. It is purely supporting that ORM functionality where every field, every table inside that organization will be representing in the form of a class. Every field inside that table will be representing in the form of a variable. Okay, in the form of a variable. Now, here you can raise a question. Sir, will this class is having only variables? Will it be having any functions? Some functions are also there. During that concept, we'll see what functions are available. In this class, Salesforce is providing 10 functions by default. Okay, 10 functions. First one is save method. Second one is quick save. Third one, cancel. Fourth one, delete. And the fifth one, first. Sixth one, next. Seventh one, previous. Eighth one, last. Ninth one, has next. 10th one, has previous. These are the 10 methods we'll be giving by Salesforce by default here. Why? Because is here, whenever I'm creating that object, Salesforce is providing what? Business logic also, along with that, the user interface also. In this user interface, what we have, after entering some data inside this particular text boxes, when you click on the save button, record is saving or not? How it is saving that record? Because of the business logic. Where is that business logic? Inside this class itself. Okay, inside the class, Salesforce is providing a method called as save method. So now that save method will be getting called upon click on that save button. When you click on cancel button, cancel method will be getting called. Inside this one, you will be having the user interface. Here we have, when you go to that enhanced list to be controlled. Here we are having the controls are available, operations are available here. I am displaying only some 10 records at a time. Here, how can we get the next remaining records inside the tabular format? Next button. Here, how many buttons are there? First button, previous button, next button, last button. 4 buttons are available here. For these 4 buttons, 4 methods has been given by Salesforce. First method, next method, last method, previous method. Next. So now after that, 2 more methods additionally here. Like, so now in this case, Now here we are having the first button and the previous button both are in disabled state. Why these are in disabled state? Because we don't have any previous record, because currently we are at the first step only right now. So now in this case, if the previous records are available, then only it will be getting visible. How do we know do we have previous set of records or not? For that one, Salesforce has given a method called as has previous. That means do we have the previous records are available or not? If it is available, buttons will be getting enabled, or else buttons will be getting disabled. Do we have any next records here? Yes. For that one here you will be having the next button and the last button is enabled for you, because it is using a method called as has next. Okay, has next. So that here we are having the next records are available. Once you click on the next button here, next records are visible. Do we have any more record? Next records are available? No. That's what here these are disabled. How it is knowing that? Because of that has next button here. Okay, clear? 10 methods will be giving the Salesforce inside this class automatically by default. Okay, save method, quick save method, cancel method, delete method, first method, next method, last method, previous method, has next, has previous. These are the 10 methods has been given by Salesforce in each and every class automatically by default here. Okay, clear? Understood the concept here? Now let's make a note of this one. Now, make a note. Each field inside the object will be represented in the form of a variable in the associated class. Each field inside in the object will be represented in the form of a variable inside that associated class. For example, account object fields will be represented as below. Account object fields will be represented as below. Now, public class account, public ID field, owner ID field, public string, name field, rating, industry, type, ownership, website, phone, fax, and then we are having website field, and we are having the building street, building city, building state, building postal code, building country, SLA, customer priority, active status, etc. We are having public decimal annual revenue, public date time, created by, last modified by. Like that you will be having that. Along with that, it is providing that methods. What methods it is providing? I mean, will be giving that list of methods to you. Like the first method is save method, and then quick save method, cancel method, delete method, first method, next method, previous method, last method, has a next, has a previous. These are the 10 methods has been given by Salesforce by default here. We'll see these methods information in the further classes. Now, done up to this variable names. Done up to this variable names. Okay. So by using these classes, we can interact with the Salesforce objects through programming. Through programming to perform the DML operations on one or more records at a time. By using these classes, we can interact with the Salesforce objects through programming to perform the DML operations on one or more records at a time. Then how can we manage the record inside this object here? Managing the record. That means how can we insert? So first of all, as a step 1, create the object of the class. Create the object of the associated class. For example, I am creating the account class object. S is equals to new account. As a step 2, assign the values for the required fields. Here I am indicating that. SEC dot name. I am indicating sample account. SEC dot rating. Some heart. SEC dot industry. Some banking. SEC dot annual revenue. Some 24 lakhs. SEC dot active status. Some years. SEC dot phone. I'm passing the value. SEC dot fax. I'm passing the value. And then as a step 3, insert the record into the object by using insert statement. For example, insert ACC. As a step 4, get the recorded details. I would like to verify. If SEC.id not equals to null, I want to get the confirmation. System.debug account record inserted with the ID. I want to show that ID here. SEC.id. These are the 4 steps we need to follow in order to manage the records inside your object. It may be any object record, whatever. Create the object of the respective class, assign the value for the required fields, insert the record by using this insert statement, and then get the confirmation of the recorded details over here. By using these four steps, we can create the records in your standard objects, custom objects, in every object also. It may be one record, it may be multiple records also, it may be associated records also will create. Then up to the step 1,